first one is 1 by z minus 1 z plus 1. Sorry, 1 plus z I want to write. Whole to the power of m. This is equal to sigma m runs from, n runs from n runs from 0 to infinity minus m n mcn combinations z to the power of n. Minus 1 to the power of n is there. So these are the 9 important Maclaurin series expansion for standard functions. By using these standard functions, we solve the particular problems. Can I move? చెప్పండమ్మా.
Yes, sir.
Okay. Now I will discuss some problems on this one. Example 1. Obtain this Taylor series expansion. Expansion of f of z is equal to 1 by z about the point z is equal to 1. So definitely the function is analytic function at z is equal to 1 So therefore at z is equal to 1, the function f of z is analytic. And what is the singular point for this function? 1 by z, z is equal to 0 is the only singular point for this function. So that is also you write down the point z is equal to 0 is the only singular point and is at a distance of 1 unit from z is equal to 1. Hence, by the Taylor series expansion, so how can we solve this particular one? So here the Taylor series expansion is already you see this one. So f of z is f of a plus f dash a into z minus a plus f double dash a by z 2 factorial into z minus a whole square and so on. Okay, from this one we write here, you put here, it is given the point is z is equal to 1. So therefore I will take z minus 1 is equal to w. We'll put z minus 1, z is equal to 1 is given, z minus 1 is w, say. So this implies z is equal to, what happens, 1 plus w. Hence f of z becomes what? 1 by z, that is equal to 1 by 1 plus w. So can I write like this one? 1 plus w all to the power of minus 1. Now you see the 1 plus w whole to the power of minus 1, the expansion you see here. This is the 1 plus z to 1 minus z. 1 minus z all to the power of minus 1. Expansion is this one. Okay. So this is the way we write. This is equal to 1 minus w plus w square minus w cube plus and so on for every mod w is less than 1. So now you substitute the, what is the w? W is equal to z minus 1. This is you substitute 1 minus z minus 1 plus z minus 1 whole square plus and so plus z minus plus or minus alternate. Minus z minus 1 whole cube plus and so on for every, what is the w? W is z minus 1 less than 1. This is the unit circle with center at 1. Okay, this is the required expansion. So to obtain Taylor series expansion of f of z around z is equal to a means what you will do, just you put z minus a is equal to w. Then f of z we write in terms of w, and that is we consider as a function phi of w. Okay, by that one we expand the system, the series. Means what is the working rule? So to obtain the Taylor series expansion of f of z about z is equal to a, around or about z is equal to a, put z minus a is equal to w. Then f of z is equal to f of w plus a. This is equal to phi of w. Same. Next, write the Maclaurin's Maclaurin's series expansion of phi of w. By using standard expansion. Finally, substitute w is equal to z minus a get the required Taylor's series. So what is the working rule? To obtain the Taylor series expansion, just you take the f of z about z is equal to a, around or about z is equal to a, just put z minus a is equal to w. Then you write down f of z is equal to f of w plus a is equal to phi of w. Using the Maclaurin series, you write down the phi of w expansion using the standard functions expansion. So these are the standard functions. The Maclaurin series expansion for standard function. These are the standard functions you take. Okay. So the previous problem 1 minus z. This is the 1 minus z all to the power of minus 1. So this is okay. Okay. So finally you substitute w is equal to z minus 1, z minus a. You get the required Taylor series expansion. So this is the working group. Next step, we'll discuss one problem on this. Expand e to the power of z as Taylor's series about z is equal to 1. About z is equal to 1. So to obtain the Taylor series expansion of f of z about z is equal to a, what we want to do? First you put z minus a is equal to w. Put z minus 1, this is 1 is equal to w. So this implies z is equal to 1 plus w. So this implies the function is given f of z is e to the power of z. This is equal to e to the power of 1 plus w. This is equal to e into e to the power of w, I will write. But we know the Maclaurin series expansion for e to the power of z is, by that one we write e into e to the power of w, we can write as 1 plus w square by 2 factorial plus w cube by 3 factorial plus and so on. For every w, we write e into, again just you change w as z minus 1. Okay, so then 1 plus z minus 1 plus z minus 1 whole square by 2 factorial plus z minus 1 whole cube by 3 factorial plus and so on. Okay, so this can be written as e to the power of z is equal to e plus e into, this is e plus e into is there, e plus e into sigma notation, n runs from 1 to infinity, z minus 1 whole to the power of n by n factorial. So if mod z minus 1 is less than infinity, for every z. Example 4. Expand f of z as 1 by f of z is equal to 1 by z square in power series of z plus 1, or another way also, this is so many times asked, prove that the same problem is written in terms of prove that when mod z plus 1 is less than 1, z to the power of minus 2, this is 1 by z square means z to the power of minus 2, becomes 1 plus sigma n runs from 1 to infinity n plus 1 into z plus 1 to the power of n. Either, so these both are same, but in terms of another way it is written. So z plus 1 solution. So f of z is equal to 1 by z square as z is equal to 0 is only the singular point. So that means z plus 1 is equal to 0. If you take z is equal to 1, means here the circle with center at 0, 0 and the radius is 1. Okay, here it is given mod z plus 1 less than 1 is given from this one to that means definitely the function is 1 by z square is definitely analytic function except at this point z is equal to 0, because z is equal to 0, the function having a singular point, and it is not analytic, okay. So therefore to expand this function as a Taylor series expansion, to expand f of z in power of z plus 1, we put z plus 1, this is equal to w. Is equal to w. So this implies z is equal to w minus 1. W minus 1. Hence, I will write f of z is equal to 1 by z square is equal to 1 by w minus 1 whole square. So this is equal to, can I write like this one, 1 by w minus 1 whole square or 1 minus w whole square. So you take negative common, but whole square is there, therefore you will get positive. Therefore 1 by 1 minus w whole square I am writing. So from this one we recall that what is 1 by 1 minus w expansion, Maclaurin series expansion. 1 minus w expansion is 1 plus w square plus and so on. This is, so here 1 by 1 minus w whole square we have, this is equal to, you will get 1 plus 2w plus 3w square plus and so on. This is the way it will go if a square is there, okay. So therefore this is the expansion I am taking, I am considering for this one. So definitely here modulus of w is less than 1, definitely. In between only, modulus of w is less than 1 means what? Minus 1 less than w less than 1. W lie between minus 1 to 1. Okay, but it is not 1. If it is 1, automatically this should be 0. This should be 0 means what? It is the function is not defined at that point. Okay. So therefore this is equal to, our f of z becomes 1 plus sigma, I will write this 1 minus w whole square whole to the power of minus 2 means this expansion we will get. Okay. This expansion I will write as n plus 1, you see, into w to the power of n. Can I write like this one? N runs from 1 to infinity. If n is equal to 1, 1 plus 1 2 w, 2w, n is equal to 0, w to the power of 0 is 1, n is equal to 0 onwards. This is actually 1 is there, 1 plus I am writing, therefore it starts from 1 only. N is equal to 1 to infinity, second term, third term, like this one. Okay, for every mod w less than 1. Okay, this is the Maclaurin series expansion. From this one we write f of z is equal to 1 plus what is the w, you write down n runs from 1 to infinity, and n plus 1 into w is equal to what? W is equal to you see w is equal to z plus 1. So z plus 1 whole to the power of n or 1 plus z, anyway we can write whole to the power of n. Okay, here also mod z plus 1 is less than 1. So this is the Taylor series expansion using the Maclaurin series. Some important problems I will give. Expand f of z is equal to z minus 1 by z plus 1 in Taylor series expansion. About the point z is equal to 0 and z is equal to 1. But about the point z is equal to 0 and about the point z is equal to 1, both two problems. The second one is find Taylor series expansion for the function f of z is equal to 1 by 1 plus z square, 1 plus z whole square, with center at minus I, with center at minus I. So here you put a is equal to what? Minus I. A is equal to minus I. Expand sin hz by Taylor series about z is equal to pi I. That means what we want to take? Z minus pi I. Z minus pi I is equal to W. You take. And you continue the previous type. So these are the previously so many times asked in the examination. These problems are very important. Expand log 1 minus z, 1 minus z when mod z is less than 1 using Taylor series. Taylor series. The last one, expand f of z is equal to 1 by z cube minus z minus 6 about z is equal to minus 1 is the first one. The second one is z is equal to 1. So this is you solve by resolving the partial fractions. So that means z cube minus z minus 6 you write down in terms of two factors. That means z minus 3 and z plus 2. You will get z minus 3, z plus 2. Sorry, this is a z square, not z cube. Z square minus z minus 6. You write down in terms of two factors, z minus 3 and z plus 2. So from that one you take two functions. For those two functions you about z is equal to -1, z is equal to 1, you write down the Taylor series expansion. Okay, Taylor series expansion. So these are the very important problems previously asked so many times in the JNTU examination. Therefore, all of you please go through these 5 problems, solve all this. Okay, so anything you want to ask, I will stop here only today's class. Tell me anything you want to ask, please. Any question?